Hi, my name is Amal Mazroui, and this is my midterm project, Proliferate, for decoding nature. So, the main concept or the inspiration is by how bacteria grow and multiply inside a petri dish, specifically through binary fission, where cells divide and expand into colonies. I was interested in how simple biological rules can lead to complex patterns, and I really wanted to translate that into a visual system. At the same time, I wanted the experience to feel slightly gamified, where the user can influence how the system behaves to different environmental conditions. So I've added these sort of like sliders here that do have like logic behind them, of course, and it influences the life and the environment of the petri dish and the colony in real time. So I thought that would be interesting to add. I didn't have that in my midterm progress, and I thought this would be very cool to have. So the system includes a simple interface with controls for interacting with the environment. So at the top here, there are buttons to restart the system, save a PNG, or to toggle the HUD. And yeah, so whenever I click on the dish, new colonies generate. And then energy controls how active the cells are. So increasing the energy makes the movement more intense, and then it's like adding nutrients or like sugar to the bacteria and makes them more energetic and move around more. And then by decreasing, they become noticeably um, either still or just move a little. And then in terms of growth, it controls how many generations the colony expands to, and it increases the density of the structure itself. And this directly sets the maximum generation, which determines how many rings of cells are created. So let me just increase the energy a bit. So you can see it in action here. It increases the density, and then at some point I won't be able to generate more than a specific amount because I've set growth to its limit. And then in terms of air, it affects how fast the motion changes, and it makes the system feel more chaotic or stable. So if I increase the air, it feels just a little bit more chaotic. Um, Let me just restart this really quick. So yeah, it affects how chaotic the system is. I'd say air and energy go hand in hand in showing how energetic the system is and how fast it works. And the way air works, it increases the speed of the noise over time, so the direction of movement updates more frequently. And then in terms of pull, it controls how strongly the cells are drawn towards the center. And this changes how tightly the colony clusters. And this is implemented as a vector force pointing inwards. So it's scaled based on how far the cell is from the center. So I'm just gonna give this a try so you can see it in action. I'll increase the air as well. So if I decrease the pull, you can see that they're not as drawn to the center, and then if I increase it. And overall, the user is not directly controlling the visuals, but they're adjusting the environmental conditions and they shape how the system behaves. So the system is built around two main components, the colonies and cells. So each colony begins at a center point, and when growth is triggered, it expands outwards in circular rings. And then with each generation, the number of cells increases exponentially, creating a proliferating structure of some sorts. So as you can see here, each cell has a base position on a ring, but it's not fixed. Instead, it moves around slightly to create some sort of randomization, but at some point it will be circular. This movement comes from noise-based motion. Technically, a Perlian noise value is converted into an angle, and that is then used to generate a directional movement vector. There's also a pull force towards the center, as I mentioned earlier, and it helps keep the system cohesive. This is calculated using a vector from the cell back to the center and scaling it based on the distance, and I used AI to help me figure this out because it was a bit confusing at some point. And then to keep the motion stable, damping is applied, and this reduces the velocity slightly, so at each frame. And this prevents the system from becoming too chaotic, which is the issue that I had in my previous prototype or in the midterm progress. And then each cell is limited in how far it can drift from its original position, and this is done by clamping its offset within a fixed radius. And then finally, all the movement is constrained within the petri dish, and this is another addition that I added. And if a cell moves outside the boundary, it's pushed back inside and its velocity is adjusted so it remains contained. And then the system balances the structured growth with controlled motion and it creates a dynamic, but it is still a stable composition. So these are the three selected outputs from the system. So the first image shows high energy and growth, resulting in dense overlapping colonies within the constrained dish. The second image uses lower energy and growth, and it creates a more sparse and distributed system. And then the third image represents a balanced state where movement and structure coexist. So in earlier versions of the project, the motion was more fluid and wiggly, as you can see. And it created trailing effects that I found visually interesting. However, the cells were not constrained within the canvas, and this caused performance issues and lag not only within P5 but my entire device. Because of this, I redesigned the system to constrain movement and I introduced a more structured growth model. The current version is more stable and responsive, although it's slightly less expressive. I would say I do like the way this looks more than the newer version. However, it would just crash, and I tried my best to solve it, but I couldn't find a solution. I believe there is a way to achieve both, but I still didn't reach that. And then I just want to have a quick AI disclosure. AI was used as a support tool for debugging parts of the code and then refining the interface, especially for the buttons and controls. AI really helped me to think things through as well and to implement the ideas that I had in my head and just give me the steps on how to achieve that. But overall, the project explores how simple rules and environmental factors can generate complex visual systems. I really wanted to give the user agency and to create whatever environment they want their bacteria to grow in. It just felt interactive and fun and could be used as a learning tool. But yeah, that's all. Thank you so much. I'm sorry if this was long. I tried to include everything that I can.